Although I suspect you are probably familiar with taking the average of a set of numbers, in this video we're going to look at how we might do that when we have millions and millions of numbers to average together. Let's start by considering the heights of the women on the Allegheny basketball team. The chart that you see here shows each woman on the team and their height in inches. You'll notice that there are a number of women on the team, 4 in fact, who have a height of 67 inches. There are 2 women that have a height of 68 inches and 2 women that have a height of 69 inches. Since there are 12 women on the team, 4 out of 12, or 1/3 of the team, has a height of 67 inches. So if we graph the fraction of the team with a given height versus the height of the women on the team, we get a distribution that looks like this, where the most women have a height of 67 inches, and then we have 2 women each with a height of 68 and 69 inches, and the rest of them are distributed among the lower and higher values of height. If we want to find the average of this distribution, we would add up all of the heights and divide by the number of people on the team, the number of heights that we have added up. So the average of the heights would be equal to, let's see, we've got 66 plus 67 plus 67 plus 67 plus 67 plus 68 plus 68 plus 69 plus 69 plus 70 plus 71 plus 72 divided by 12, because that's the number of heights that we are averaging. Let's rewrite this a little bit by grouping all the heights together that are the same. So we can write 66 plus 4 times 67 plus 2 times 68 plus 2 times 69 plus 70 plus 71 plus 72, again divided by 12, because that's the number of heights that we're averaging together. We can do a bit more algebra on this by recognizing that we can divide each of the numbers in the numerator by 12, so that we get 1/12 times 66 plus 4 divided by 12 is 1/3, so we have 1/3 times 67 plus 2 divided by 12 is 1/6, so we have 1/6 times 68 plus, again, 1/6 times 69, and then there's 1 of each 70, 71, and 72, so we have 1/12 times 70 plus 1/12 times 71 plus 1/12 times 72. If we take a moment to look at this last result that we got, we can see that each height that shows up in the height distribution, is multiplied by the fraction of times that it shows up in that distribution. So we can write a general formula for the average, which is the sum from the first value that we have in the distribution to n, the last value that we have in the distribution, of the fraction of each property that's found in the distribution times the value of the property being averaged. This way of taking an average is often called a weighted average because each value of the property that you're trying to average is weighted or multiplied by the fraction of times it shows up in the distribution. And then that's all summed together to give the average. This concept is completely general and can be applied to finding the average for any property in any distribution.